We can now begin laying out our DOPNet, so let's do that. Let's jump inside that DOPNet. Let's give ourselves a bit more space with the network editor, expand the window. We're going to put down two static objects. One is going to be the ground plane that we're going to be reintroducing, and the other will be the bounding box that we've just created. Another thing we're going to put down is an RBD packed object, and that's going to be for our building bounding boxes. Let's grab these three, move them up, put down a merge node because we want to merge those together. We can just select all of those three objects and put them into the merge node. So because we're going to be doing RBD simulations, we're going to need a bullet solver to detect the collisions. And because we're going to be treating the buildings as single points, so particles basically, we're going to also need a pop solver. Let's put that down. We can merge those together, again with a merge node. Let's also put down a multi-solver. And then in the multi-solver on the left side, we're going to introduce the object, while on the right side, we're going to pipe in both of the other solvers. And we're going to need a gravity force. So let's put down that gravity force. Then we're going to pipe the multi-solver into the left input of the gravity, and the gravity into the output. And because we're going to be using those points to attract the buildings, we're also going to need to drop down a pop attract node, and we're going to wire that into the pop solver. Let's put down that pop attract and wire that in. Since we'll be reintroducing our ground object, let's go and pick that up. Let's go up one level and up again. And inside our building clusters, we did configure this ground object in case we might need it again. And here we go, we actually do. Let's just bring it into our city block sim. Paste it here, so now we have one here as well. And let's jump back inside our DOPNet. Then in our static object, let's call it static object underscore ground and wire that up. So let's find the subpath to that ground object. There we go. So that's imported. We can zoom out a bit in the viewport to see that we've imported correctly. There it is. Now the other static object is going to be the bounding box that we've just created in the previous video. So let's call it static object underscore vbox. And let's find the subpath to this. We've given that an out name, so that should be at the top, and that would be out bounding box dops if we remember correctly. And now if we import that, we can see that we have that one there as well. And then for the RBD packed object, let's fetch our buildings. In the subpath, we can find the out city block. And there they are, they show up in the viewport as well. So now we have the bounding box, the ground plane, and the buildings. Let's jump back up. And then in the DOP import, we now know what to call this. The object mask is going to be RBD packed object 1. And now if we visualize that, we should see our buildings there. It's erroring out. We have to set import style to fetch packed geometry from DOP network because that's what it is. This also allows us to see more clearly if we simulate what happens. So let's visualize the DOP import node and press play. So we can see that there's a lot going on. They're clashing, bouncing, falling through, simulations going all over the place. To change that, we're going to change a few settings. Let's stop that and rewind it with the back arrow. Let's jump back inside our DOPNet and have a look at the ground object, static object underscore ground. If we scroll down and look at the physical tab, we can see that we have bounce, bounce forward, friction, all these settings. We're not doing an actual simulation. This would be useful if you have a bouncy ball, for example, and you wanted to bounce a bit forward and use its forward force to sort of keep going, momentum, etc. All we want to do with our simulation is align buildings to a grid. It's got nothing to do with reality. What we can do is turn all these settings to 0. No friction, no dynamic friction, no bounce, no forward motion, none of this. And we can do the same on our red bounding box, just turn them all to 0. Now let's jump back up. On the simulation tab of the DOPNet 1, hit reset simulation, visualize DOP import, and play that again. It's a bit less aggressive, no more jumping and bouncing around, but it's still not quite what we want. So let's change a few more settings. Let's stop that, rewind it, and jump back inside. Let's examine the buildings, the RBD packed object 1. Let's expand the top window a bit. Now if we look at the physical tab, we should have similar settings as the ones we've just changed. So for example, there's rotational stiffness, mass, bounce, and friction. We want to turn bounce and friction down. I don't want them to bounce. There doesn't have to be any friction. Rotational stiffness is a setting that before we've changed to 0. What that does is it avoids these objects from spinning around their own axis. When we wanted to create a grid-like structure, that's what we wanted. But for example, in the city block, we have a curved edge, and we want the buildings to rotate against it. So we do actually want to leave rotational stiffness at 1. Let's just jump back up one more time, reset the simulation, visualize it up, import, and play again, and see what changes this time. Not much. Let's just stop, rewind, and continue tweaking settings. Now, as you know, we want to attract the buildings to the outside edges, but the buildings currently are just jittering around. So we need to configure the pop attract. Let's click that. Let's open the top window a bit more. On the goal tab, the attraction tab, we're going to set 2 points, and then we want to specify the subpath. So the subpath to the out node where the points are stored. So if we open that up, we can see that we have our out pop attract as we've created in the previous video. Let's accept that. No need to configure the other things. On the same tab, on the goal tab, there is this number of clusters setting. This we want to be the same number as we have points, because we want every single point to be an attractor. So we can use an endpoints expression for this. So let's just copy this path, Control C that, and the number of clusters remove the 1. I'm going to hit Alt E to expand the window, and I'm just going to paste that path. And I'm going to wrap that with an endpoints expression. So endpoints, open brackets, and close. And of course I'm going to need my quotation marks. 1 at the start, 1 at the end. Hit apply, accept. And now if we middle mouse on it, it already evaluates to 1000. And that's exactly what we want, because in our scatter points, we have 1000 points. So that adds up. We don't need that many points though. So let's expand our network editor a bit, jump up, and let's find our out pop attract right there. Our scatter node is here, and let's just set that to 500. It will make our simulations a little bit easier. Now if we visualize that, the out pop attract, that is, we can see we still have plenty of points around our block. So that's good. Let's revisualize the DOP import and jump inside the DOPNet, and we can see here that there are now 500 points in number of clusters. Let's have a short break and continue in the next clip.